All right, guys, this time we are going to start with mole to mass. So your paper that you picked up today in class has mole to mass calculations on one side, and it has mass to mass on the other side. We're going to start on the side that says mole to mass. All right, so if you will flip to that side, and I just want to heads up you that after today and the lack of doing homework that I've seen and the lack of working in class time that I've seen, I am popping a quiz on you tomorrow. So those of you who actually did your homework are going to be forewarned. Those who didn't are going to be sorry. So let's go ahead and look at problem number 1. It says, how many grams of iron are needed to produce 7.70 moles of iron 3 oxide? So we're going to circle that and label it our given. So in this problem, my goal is to get from the given to the unknown, to get from moles of iron oxide to grams of iron. All right, so I'm going to set up my grid. Given goes top left with units. So I'm going to put that 7.70 moles of Fe2O3 here. Okay, top left has to match bottom right, so I'm going to put moles of Fe2O3 here. I'm trying to get to grams of iron, but I don't have an equality for moles of Fe2O3 to grams of iron. There is no equals there. I can go mole to mole though, so I'm going to put moles of iron here, and then from moles of iron I can go to grams of iron. Alright, so I've got mole over mole, so remember what I told you to do, circle it, label it the mole ratio. You will do this on your paper every single time or I will take points off. It is essential to me that you show me that you know what the mole ratio is. Now, rule number 5 says moles always gets a 1 except the mole ratio. So I'm going to put a 1 next to this mole, but for the mole ratio I'm going to use the coefficients of my balanced equation. So I've got iron on the top, so I'm going to use the 4 coefficient from iron next to iron. And next to Fe2O3 I have a 2. Now, I had a great question asked today. Do I reduce the mole ratio? No, no, no. Because it's going to work itself out, and that's just extra work you don't have to do. So even though you've got 4 over 2, you don't have to simplify that to 2 over 1. Leave it 4 over 2, okay? Just leave it. All right? Rule number 6 says grams always gets molar mass. So our molar mass for iron is 55.85. So I'm going to put 55.85 in for grams. So then I'm going to multiply across the top, multiply across the bottom, divide the top by the bottom. Now, one thing that I saw a lot of kids making a mistake on yesterday was that when you have more than one number on the bottom, they didn't put that in parentheses. If you got more than one number on the bottom, you got to put parentheses around that before you divide. So I'm going to take 7.70 times 4 times 55.85. And then I'm going to divide that by parentheses 2 times 1 parentheses. Okay, so that's going to get me, and I have run out of room, 860.09. I need 3 sig figs, so I'm just going to round that to 860 with a decimal. And that is grams of Fe. Put it in a box, we're done. Okay? So this is just about going from point A to point B. Okay? Number 2 says, if 4.5 moles of oxygen reacts with iron, what mass of iron 3 oxide will be produced? We got the word mass. Mass is grams. So label that guy grams, and then label this guy over here the given. Okay, let's go ahead and set up our grid. Given goes top left with units, so we're going to put our 4.5 moles of O2 here. Top left matches bottom right in the units, so I'm going to put moles of O2 here. I'm trying to get to iron 3 oxide, which is Fe2O3 in our balanced equation up here. So I'm going to go to moles of Fe2O3. That's not what I want, though. I want grams. So I'm going to take and pull that back down, moles of Fe2O3 to grams of Fe2O3. Okay? So I've got moles over moles, so I'm going to circle moles over moles and label it the mole ratio. You will do this on your paper, or you will get points taken off. You have to show me that you understand what the mole ratio is. Rule number 5 says moles always get to 1 unless it's in the mole ratio. So for the mole ratio, I look at the coefficients. Next to Fe2O3, I have a 2. Next to O2, I have a 3. And then grams always gets molar mass. So we need the molar mass of Fe2O3. Okay, so we're going to take 2 irons plus 3 oxygens, and that's going to get me 159.688 grams of Fe2O3. So now all that's left to do is multiply across the top, multiply across the bottom, divide the top by the bottom. And again, make sure you put that bottom in parentheses because we've got more than one digit there. Okay, so I'm going to take 4.5 times 2 times 159.688 divided by parentheses 3 times 1 parentheses. Running out of room. So that got me 479.064. Rounding that to sig figs, I need 2 sig figs, so this would just be 480, no decimal, and that's going to be grams of Fe2O3. All right, so those are the mole to mass calculations. So let's go ahead and flip this over and look at mass to mass. So this is really the most practical one because we don't have anything in our lab that measures moles. So moles is really just the means to an end. Moles is what's going to allow us to go between compound A and compound B. But we can't really physically measure moles. So we have to start in grams, and it's helpful if we end in grams. So let's talk about a gram to... All right. So in this one it says, what mass of copper is produced if 200.0 grams of aluminum reacts? So this is my given. Remember, mass is grams. So I'm going to set up my grid. 200.0 grams of aluminum. Okay? Now remember, rule number 4, the only place to go from grams is to moles of that same substance. So I've got grams of aluminum here. The only place I'm going from there is moles of aluminum. That's the only thing I can do. That's not at all what I want, so I'm going to have to keep on going. So I'm going to take top left down to bottom right, so I'm going to bring my moles of aluminum down. Now I can go mole to mole. So I can go from moles of aluminum to moles of copper. So I'm going to go from moles of aluminum to moles of copper. And then once I've got moles of copper, I can then go from moles of copper to grams of copper. Okay? Now I've got moles over moles, so remember we're going to circle that and we're going to label it the mole ratio. You will do that every single time or I will take points off of your paper. I hope I've made myself clear about that. Alright, so moles always get to 1 unless it is in the mole ratio. So the other 2 moles get a 1, but the moles within the mole ratio, we need the coefficients from the balanced equation. So next to copper, I have a 3, so I'm going to put that 3 next to copper. Next to aluminum, I have a 2, so I'm going to put that 2 next to aluminum. So I'm going to take, oops, just kidding, Miss Crane, I need the molar mass of aluminum and of copper, because grams always gets molar mass. So aluminum is 26.98. And copper is 63.55. So now remember, when you put this in your calculator, we got to use parentheses when we're dividing. So I'm going to take 200.0 times 1 times 3 times 63.55. Enter. Divided by parentheses 26.98 times 2 times 1 parentheses. So that's going to get me 706.6345, blah, da, 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 da. I need 4 sig figs, so that's just going to round to 706.6, and that's going to be grams of copper. Okay, so that's all number 1. I know it bled into number 2, but that's all for number 1. All right, let's look at another problem. Number 2 says, what is the mass of aluminum nitrate that is produced if 100.0 grams of aluminum reacts? So we're going to circle 100 grams of aluminum and label that the given. Mass of aluminum is what we're trying to find, so we're going to put the given in the top left. So we're going to do 100.0 grams of aluminum. All right, remember rule number 4, the only place to go from grams is to moles. So the only place I'm going here is from grams of aluminum to moles of aluminum. That's all I can do. Okay, so moles of aluminum, and I want to get to aluminum nitrate. Okay, so I'm going to look up here. Aluminum nitrate is AlNO33. So I'm going to put my moles of AlNO33. Okay, now I don't want moles, I want mass, which is in grams, so I'm going to do moles of AlNO33. Sorry, I'm running out of space, guys. It's really hard to write with my finger. There we go. And then grams of AlNO33. You know what that says. All right. So I've got moles over moles. I'm going to circle it and label it the mole ratio. You will do this every time on your paper, or I will take points off. Okay, moles always get to 1, except if it's in the mole ratio. The mole ratio gets the coefficients from the balanced equation. So next to aluminum, I have a 2, so I'm going to put that same 2 here. Next to aluminum nitrate, I also have a 2, so I'm going to put that 2 here. So multiply across the top, multiply across the bottom. Just kidding, I need my molar masses. Aluminum is 26.98. And aluminum nitrate, we're going to have to add that guy up. We have aluminum, Al, nitrogen, N, oxygen, O, 3 parentheses 3. That gets me a mass of 212.996 grams. All right, so I'm going to take in my calculator 100.0 times 1 times 2 times 212.996 divided by parentheses 26.98 times 2 times 1, close the parentheses. That's going to get me, sorry I'm running into number 3, this is still number 2, 789.4588584. Rounding that to 4 sig figs, okay? The number after 4 is greater than 5, so I'm going to round this to 789.5, and that's grams of AlNO33. Okay? Let's look at one more. If 30 grams of aluminum nitrate is produced, how many grams of copper 2 nitrate are needed? Okay, so this is my given, and that's going to go in the top left with units. Top left has to match bottom right, so I'm going to put my grams of AlNO33 here. Okay, and remember the only place to go from grams is to moles, so we're going to do moles of AlNO33. Oops, that's a 3. Okay. Now I don't want aluminum nitrate, I want copper nitrate, so I'm going to move from moles of AlNO33 to moles of CuNO22. And then moles of CuNO22 to grams of CuNO22. I'm out of space, so this is going to be grams CuNO22. I hope you guys know what I'm talking about there. All right, moles over moles. So I'm going to circle that, and I'm going to label it my mole ratio. You will do this every single time, or I will take points off of you. Okay? Moles always gets a 1, except for the mole ratio. So these two moles are going to get a 1. My mole ratio gets the coefficients from the balanced equation. So next to copper nitrate, I've got a 3, so I'm going to put that 3 here. Next to aluminum nitrate, I've got a 2, so I'm going to put that here. Grams always get smaller mass. We already calculated aluminum nitrate. He was 212.996. And then we need copper 2 nitrate. So that's going to be copper, nitrogen, add that all together, and that gets you 187.556. So we're going to multiply across the top. 30 times 1 times 3 times 187.556. Remember now that we're dividing, okay, so take your answer and divide it by the parentheses. 212.996 times 2 times 1. That should get you 39.6, which we're rounding to just one sig fig, so that's going to be 40, and that's grams of CuNO32. All right, I hope that that was not terribly confusing. These are the harder problems, so we will work on these some more tomorrow in class after we take the quiz. So have a good